Hi everyone, I'm at the Energy Institute. My research started in 2009 at Manchester, and then I transferred to UCL Bartlett School of Graduate Studies, and since then transferred to the Energy Institute, so I've got sort of a broad spectrum of Bartlett experience. My PhD came about because I was involved in an architectural project in Saudi Arabia, and it was for Foster and Partners creating the first sort of large-scale development in Riyadh, and it was a LEED platinum building. So it sort of led me on to Masdar and the kind of questions that I'd like to ask about the sort of benchmarks between making a city in the desert sustainable, high quality. This is a picture of a transitional space. Unfortunately, you can't see the green on it, but I'm just going to turn this around so you can see part of the sections on it. The green area here is transitional spaces, also known as communal spaces. They're atriums, they could be lift lobbies, they're entrance areas. These are spaces that you typically use to transition from one space, from the outside into the actual building, to a steady state environment. You ask me, what is a steady state environment? They are typically areas that would be the 21 degrees Celsius as soon as you go into an office or a sort of a study area. But there are spaces before that, like this photograph that you see of the 1960s and 50s of Abu Dhabi, where those kind of modern buildings weren't really present. And so these kind of palm fronds and very old type of vernacular architecture was used to keep people comfortable in a desert environment. And you're looking at temperatures soaring to about 60 degrees Celsius. This is Qasr Al Hosn, it's in the center of Abu Dhabi. At present, it's surrounded by quite a lot of modern architecture, and I'll show you that soon. But these kind of environments where you have the courtyard appeal, where air would sort of pass through, you would have open spaces for families to congregate, very thin walls in order for people to walk through the environment and not be subjected to extreme highs, extreme heat. A lot of stone was used. This is Aleppo. I visited Aleppo in 1990 and then again in 2010. I was taken around Aleppo by an architect called Adli Qudsi, who had revived Aleppo since 1984. This is Masdar city. Again through the Foster and Partners scheme that we worked on in Riyadh. But this shows this sort of courtyard appeal of this microclimate that you can use to reduce the impact of temperature on people who are walking through these environments. Now, what happens when in a modern environment like Abu Dhabi, where you have, 8 lanes or 10 lanes, and in Dubai where you're on the motorway, creating this microclimate, an urban heat island effect, which is effectively just heating up as time goes on, like we have an issue in London where London is heating up. This urban heat island effect is creating a sort of a bubble of heat, and so in the midst of the summer you'd probably walk for about 10 minutes before you really thought you were about to die. So you can really feel this heat stress. So from walking from one end of the street to the other is so painful that, and here is an example, just during the daytime, of the different kinds of landscape that you can have, the urban landscape. Here you have desert, where it can reach something close to 67 degrees felt temperature, or let's say a shaded area where it might be 47 degrees. This is the night time, and so what we're trying to do is create this sort of level, a tiered level of shading, of microclimate, of the use of this transitional area as a medium before you walk into these steady state environments, to change the temperature of these environments and make it much more comfortable for you to transition through the building. So if you're moving from 45 degrees outside to 21 degrees indoors, then there should be some area in between that allows you to adjust to this internal environment. And this is predominantly what my research is about. And there has been a lot of researchers that have looked at thermal comfort and thermal comfort and the psychological states and the physiological states of steady state environments and transitional zones have been the key sort of factors in pushing the design and engineering of buildings. But one of the real issues that we're having is that there is no conformed idea of what a transitional space is, and there is no design specifically for these spaces. They're zoned out of the architectural designs, and this is becoming a really big issue. So, but in Abu Dhabi, let's say, going from 45 degrees, as I mentioned before, to 21 degrees is quite a shock to the system. Outside, we're at probably 15 degrees, and if you're walking into maybe 18, 19 degrees, it's not that much of a differential. However, there are different ways that you can create a comfortable environment, and this is an example of Masdar City, where they've used a variety of heights of buildings to introduce wind into the environment. They're examples of the uses of the designs that people can have in a hot climate. However, there are other ways of doing it. So, for example, if you're looking at agriculture, urban agriculture in the environment, that can really reduce the felt temperature. So you're not walking directly in sunlight, but you could be in shading. And there are other uses of that. So, for example, reorientating your building. The next image, when it comes, is all about reorientating the building so that the sunlight, as soon as it comes and passes around the building, is not directly through the glazing, which only heats up the building itself and makes it much more uncomfortable for whoever's sitting next to the window. I'm sort of widening the thermal comfort parameters in these transitional zones, because steady-state environments are quite difficult to manage, and ASHRAE's pretty much got its standard down on what is comfortable. But these transitional spaces don't necessarily have a definite comfort parameter. And so in my research, I've widened this just by 1 degree. And from this research, I've realized that you could increase the thermal parameters by up to 5 degrees without changing the perceived comfort of the occupants. Thank you very much for listening.